All right, let's get right into it. Today, we're going to tear down how you think about atoms and rebuild it with a really simple idea: the electron parking garage. It is time to learn the real rules that decide where electrons actually live. So, you probably remember from science class that electrons fill up their shells in this nice, tidy little pattern. Two in the first one, then eight, then another eight. It's clean, it makes sense, and, well, it's not exactly the whole truth. It's time to talk about what's really going on. Here's our game plan. First, we're going to bust open the full shell lie. Then, we'll introduce our new model, the electron parking garage. After that, we'll get into its super weird parking rules and, more importantly, why they're so weird. We'll bring back the magic number 8, and then we'll see why any of this actually matters in the real world. Okay, let's just rip the Band-Aid off. That idea that a shell has to be totally full before electrons start moving into the next one, that's where the old model just falls apart. The reality is a little messier, but trust me, it's way more fascinating. This quote right here just nails it. The shells do have a maximum capacity, a hard limit. But that doesn't mean they always fill up to that limit before the next shell gets its first electron. Think of it this way. Max capacity is just one part of the story, not the whole rulebook. So, to really get a grip on this, we're going to throw out that old image of electrons orbiting a nucleus like planets. Instead, I want you to picture a giant, multi-level parking garage. This is a much, much better way to visualize what's actually happening inside an atom. Let's build this garage together. It's pretty simple. First, you've got the main floors, the levels. These are basically the same as the old electron shells you already know. But, and this is the key, each level is split up into different parking sections. This is the detail the old model totally misses. Okay, so the levels, or floors, get bigger as you go up. Level 1 can hold 2 cars, or electrons. Level 2 can hold 8. So far, this matches the old rule, right? But here's where it gets interesting. Level 3 can actually hold up to 18 electrons, and level 4 holds a whopping 32. The formula is 2n squared. But again, just because it can hold that many doesn't mean it fills up that way. Now, for those parking sections, the higher the level, the more kinds of sections you get. Level 1 just has one little S section. By the time you get to level 4, it has 4 different types: S, P, D, and F. And each of these has a fixed number of spots. S always holds 2, P holds 6, D holds 10, and F holds 14. You add those up, and that's how you get the total capacity for the level. Okay, our garage is built. We've got our levels and our sections. Now we need to figure out how the electrons actually park. And this, my friends, is where things get really, really weird. They don't just fill up level 1, then level 2, then level 3. Oh no. They follow a very specific and kind of bizarre path. So, the logical thing would be to assume they fill up all 18 of those spots on level 3 before they even think about starting on level 4. Makes sense, right? It's orderly, it's clean. And there's the twist. The answer is nope, not always. This is the exact point where that simple 2-8-8 rule completely breaks down. So, what is the rule then? Just look at this. On the left is what we'd expect. After the 3p section is full, you move on to 3d to finish off level 3. But in reality, look at the right. The electrons take this crazy detour. They actually start parking in the 4s section, on the next level up, before they go back to fill in the rest of level 3. It's wild. Let's make this real. Let's look at an actual element that does this. Everybody, meet potassium. It's got 19 electrons, and they all need a parking spot. Now, the first 18 park pretty much how you'd expect. But that 19th electron, it's our rule breaker. And here it is, the moment of truth. You can see after the 3p section is full, there's still a huge empty d section on level 3 just waiting for electrons. But does that 19th electron go there? No way. It skips right past all those empty spots, drives up the ramp to level 4, and parks right there in the 4s section. Now this seems totally nuts, right? But I promise you there is a very simple, very elegant reason for all this chaos. It has nothing to do with the level number, it's all about energy. This is it. This is the one rule that governs everything. Electrons are lazy. Fundamentally, deep down lazy. They will always, without fail, go to the easiest, lowest energy parking spot available to them. And sometimes the easiest spot isn't where you think it would be. This analogy makes it all click. Imagine you're carrying a bunch of heavy groceries. You've got two choices. Walk up to the third floor and all the way down the hall to the back apartment. Or take the elevator to the fourth floor to an apartment right next to the elevator door. You're taking the elevator, right? It's the lower energy option. For an Electron, parking in that 4S spot is like taking the elevator. It's just easier than walking all the way back to the 3D section on level 3.
Okay, so if level 3 can really hold 18 electrons, why on earth did we ever learn the rule of 8? Because it turns out having 8 electrons in that outermost level, even when the level itself isn't technically full, gives the atom a very special kind of stability.
8. This is the magic number. This number is the key that unlocks pretty much all of chemistry. It's the reason atoms react, why they form bonds, and how they build every single thing around us. But why? You see, when an atom has 8 electrons in its outer level, it means its S and P parking sections are completely full. It's like having a perfectly balanced, efficient work crew. Everything is just right. And this leads to the most critical shift in thinking. Atoms aren't trying to be full, they're trying to be stable. And 8 outer electrons, that's the ultimate stability. So we've got this cool theory about atomic parking garages and lazy electrons, but so what? Why should you care? Because this seemingly weird system explains the properties of literally everything. The whole reason sodium and chlorine get together to make table salt, they're trying to get that stable 8. The reason iron is magnetic, it's all about how electrons fill those weird D sections. Why copper is an amazing conductor of electricity? It's because of its own strange electron setup. It all comes back to these parking rules. So, let's sum up the real rules. Rule 1. Shells can hold a lot more electrons than you were taught, but their max capacity isn't the main story. Rule 2. Electrons are lazy. They park in the lowest energy spot they can find, even if it means skipping to a higher level. And Rule 3. 8 outer electrons is the ultimate goal for stability, and that drive for stability is what powers all of chemistry. And that leaves us with one final, fascinating question. If this powerful drive to get 8 outer electrons is what makes atoms react and form bonds, what about the elements that are just born with that perfect, stable arrangement already? Well, that's a story for our next explainer. See you then.